Hello, this is Hudson Valley Statistics 220, and this is the first video on Chapter 1. Chapter 1 is Descriptive Statistics. You should print out your handout to follow along with my videos or my PowerPoints. You should always have your calculator handy and your formula sheet. If you have any questions, you can always contact me via email. You must use your Hudson Valley email, and I will respond to you. You're welcome to also call me at my Hudson Valley phone number and leave a message, and I will get back to you. But I would like to start with Chapter 1, which is Descriptive Statistics. I often in my videos will go to the doc cam so you can see your handout or my handout and follow along. So I am going to jump over to the doc cam right now, and this should be a similar handout that you've printed. If you want to pause it and go print out your handout, that would be important. Now, statistics. First chapter we talk about statistics, and statistics, you just need to write down the 5 important words for statistics. That is collecting, organizing, presenting, analyzing, and interpreting data. Most of Chapter 1 will be vocabulary. The next vocabulary word we have is descriptive. Chapter 1 through 4 will be descriptive statistics. You can get the definitions from the textbook or my PowerPoints. However, in parentheses, I tell students to put the word historical. In other words, it's data we've collected and we're going to massage it. We might put it in a chart, or we might put it in a graph, or we might just summarize it. Okay? It's historical data, maybe from 2010, 2011, and 2012. This is Chapter 1 through 4. Chapter 5 and on in this course will be inferential statistics. Again, you can get the definition from the textbook, but I have students think of it as predicting or looking into the future. I might say to you, okay, the admissions here at Hudson Valley or enrollment has been 10,000 for the last 2 years, but we are going to predict it for the next 5 years, and we predict it's going to go up to 11,000. Throughout the semester, we'll use statistical techniques to predict data, and that's called inferential statistics. 2 words that you also have to know the meaning: population, are all objects. Sample is a portion of objects. When I say objects, it could be desks, it could be people, it could be bugs, it could be textbooks. Now, sometimes it's hard to determine whether it is a population or sample. I have 30 students in front of me right now. Are they a population or are they a sample? They are both. They are the population of my statistics class, but they're a sample of maybe all of students here at Hudson Valley. Qualitative data is non-numeric. An example is gender. Quantitative data can further be broken down into discrete and continuous. Discrete data, you count it. There's gaps between the numbers. If I count the number of TVs in your home, there might be 3. There's not 2.54 TVs in your room. It's counting. Continuous data is typically measured. Measured the weight of a piece of meat. Maybe measure the temperature. An example of continuous data that people often forget is money. Money is continuous. A bank will round money to 15 to 17 decimal places. Continuous data is a weight or money or temperature. These 4 levels of measurement you should be familiar with. I asked maybe one question on the test on them, but depending on the level of measurement, we can do different statistic techniques. So nominal level, it's just a label. There's no order. For example, a make of a car, Honda, Toyota, Ford, or GM. It doesn't matter which one I order first. Ordinal level is a ranking. There is order and some meaning to order. Ranking in high school, you might be the 50th in your class or the 51st in your class. The difference between 50 and 51 ranking, there's no measurable difference, or it's not feet or inches. Interval level, there is difference between the numbers that are ordered. There is meaning between the distance between the numbers. However, there is no meaning to 0. The best example is temperature. Between 32 and 33 degrees, there's 1 degree, and that's measured. Okay? But also with interval, if I tell you the temperature is 0, does that mean there's an absence of temperature? No. It just means it's cold. However, ratio level does have meaning to 0. An example of ratio is money. If I say I have $0 in my pocket, there's an absence of money for sure. And if I have $10 and you have $5 in your pocket, I have twice as much. You can turn the data into ratio. Just quickly, these last 2 comments, ethics and statistics. Go to my PowerPoint and look at the magazine example I gave you. But I'd like to show you one other example here with ethics. Let's say I'm a financial advisor, okay? And you want to know how you're doing. Well, this is January, February, March, April, and this is your stock value. It went from $10 a share to $11 to $12 to $13. Wow, that looks great. You should keep investing with me. However, I could go to another financial advisor, graph the exact same data, and this is what the graph looks like. 11, 12, 13. It looks like it's really flat. It's the same exact data. I only changed the scale here. Possibly both of these are unethical. Be careful when you look at data. Find out the source. And this last spot, computer applications, almost everything we do in statistics has a computer application. I encourage you to practice with discrete, qualitative and quantitative, and discrete and continuous. I also encourage you to fill out examples here in Chapter 1. Chapter 2, it's when we talk about frequency. Okay? Qualitative data, which is non-numeric data, is graphed as a bar chart. Okay? The bars are not touching. Frequency is your axis, maybe 10, the number of cars sold. Ford, GMC, and Honda. Okay? It's non-numeric data here, the makes of the cars. Quantitative or numeric data is graphed as a histogram. Mutually exclusive data falls in one class, and class are the groups. I have a video that discusses histograms further, but a histogram Might be the age here at Hudson Valley. Maybe we have 17 to 19 to 21 to 23 to 25. Okay, and this also is frequency. This might be 1,000, 2,000, 3,000, 4,000. Histogram. The bars touch. It's a numerical, it's quantitative data on the horizontal axis. You can look at my other video for more information on histogram. So, and we just discussed a bar chart to describe data, qualitative data, histogram, quantitative data, pie chart. It's for percent. Or sometimes we use, and we'll talk about this in a minute, relative frequency data. Class interval, class midpoint, and class frequency. I'm going to tell you to go to my PowerPoints to get those definitions. Relative frequency distribution also. Let's look at relative frequency here. This one example. We have sold, and let's look at this data. Our sample size N is 80. We sold 80 cars. 50 of them were domestic, 30 were foreign. To calculate relative frequency, you take the frequency divided by total sample size, and we got 0.625. To calculate the relative frequency for foreign cars, it's 30 divided by 80, or 0.375. Okay? These numbers are can be used to graph a pie chart, or they typically just look at the other classes, the relationship to other classes. This one's at 0.625, this one's 0.375. So, the majority of our cars sold were domestic. At this time, I recommend you pause and you calculate relative frequency. Now I would like you to teach you how to calculate cumulative and midpoint. Cumulative frequency, you copy over the first frequency, in this case it's 8. Then the next cumulative frequency, you say 8 plus 23, or 31. The next cumulative frequency is 8 plus 23 plus 17, which is 48. The next relative frequency would be 8 plus 23 plus 17 plus 18, which is 56. And I'm going to let you calculate the other three. I'm going to go over to midpoint. Cumulative frequency we're going to use to graph a graph in a couple of minutes. Midpoint. Midpoint is the midpoint between the two ends of the class, 15 and 18. How do you calculate it? If you can't do it in your head, you say the lower end, 15 plus 18 divided by 2 is 16.5. This midpoint would be 19.5, 22.5, 25.5, and I'm going to let you continue on with these so you have a little bit of practice. So you need to know midpoint for calculations and graphing, cumulative frequency for a graph, and relative frequency to graph a pie chart. Now, look at the classes here. Each one of these is a class. In this, we had 1, 2, 3, 4, 5, 6, 7 classes. How did I determine 7 classes? I use the 2 to the k rule. The 2 to the k rule, we take 2 squared, 2 to the 4th, 2 to the 5th, 2 to the 6th. Get out your calculator, 7th, and 2 to the 8th. We calculate those. 4, 8. Oh, I forgot 3. 4. Oh, here's 5, which is 2 cubed. I forgot. 8, 16, 32. Sorry about that. 64, 128. Forgot the easy one. And 256. 2 to the k. We have to have 2 to the k is greater than n. N in this case is 80. So we have to have 2 to the k is greater than 80. Which one of these numbers is greater than 80? 4, 8, 16, 30, 42. Right here. This is the winner. 2 to the 7th is greater than 80. That's greater than 80. So therefore, k equals 7. 7 classes. That's how I determined there would be 7 classes here. For example, 3 classes would have been too few. We couldn't have made a good decision. 10 classes would have been too many. The ideal number of classes here is 7. The other decision I have to make is the distance here. How did I come up with 3,000 here? Well, that one, I use the interval formula. I has to be greater than or equal to the highest number minus the lowest number divided by k. So if you go to my PowerPoint, you'll see the raw data. When the raw data and my PowerPoints, we find the high minus the low divided by k is 2,911. We wouldn't use this oddball number as the interval. We round up to an interval of 3,000. So I equals 3,000. Okay? You will do this on your first graphing assignment. What I recommend now is on your handout, I have profits for 180 cars sold. I recommend you practice cumulative frequency, midpoint, relative frequency calculations, and then practice drawing a histogram and a frequency polygon and a cumulative frequency polygon. All of those are demonstrated in my PowerPoints and in the textbook. This example, I believe, is in the specific example is in the textbook. That concludes both Chapter 1 and Chapter 2. I just did it in a few minutes. You really need to read, do the homework problems, and if you're an online student, you must do the Connect required problems for the 2 chapters. At the end of Chapter 2, there will be a test. So, as I said, this concludes both Chapter 1 and 2. It was a very short video. It usually takes me 2 weeks of class time to go through this. I gave you a summary. You do need to go through the textbook to get the details and more definitions. And thank you for your time.